Hello, my name is Nicholas Delgado, and this is my final presentation for Eric Chou's Programming Languages class. The topic I decided to work on was creating my own Scheme to Python interpreter. The main idea of this project is pretty simple. First, I created some test scheme code, which I will showcase in the next slide. My program will then allow me to display that specific code, but in a Python environment. I chose this topic because out of the other three options given, I felt like this one would help me more in my line of work that I would like to pursue. As we can see here, I am showcasing three functions that my interpreter will be able to produce. The first being the ability to print text, as seen with all the display lines. The second being simple math, as seen such as assigning variables and addition. And the final function is the ability to reverse a given list. The code that I used to reverse a list is the same code that I submitted earlier in the year for a previous assignment in this class where we reversed a list using Dr. Racket. So for our first file, we have env or environment, which houses three functions and a class. For starters, I chose to wrap this in a class in order to use the idea of inheritance and support the nested functions within it. For the init function, we use this to create an entirely new environment whenever we call for functions to be used. For the find function, it looks up a variable in the current or parent environment. It then returns the environment when the variable is located. For the standard environment function down here, I use this to create a dictionary that houses all of my necessary logic functions. In the evaluation file, this is where all the interpreter's logic is stored. It evaluates parsed expressions through the use of abstract syntax trees. To break this down, starting from top to bottom, if x is a string, then it is a variable where we then look up its environment. If x is a number, we then return it in its current state. If it is a list that starts with define, we either store a variable or create a Python function. If x starts with display, we print it. And if it starts with if, then we test it to find its state. If it comes back as true, we evaluate the consequence. If not, we evaluate the alternative instead. For the first part of parse, I had to equip it with some defensive capabilities so that it checks for empty tokens before actually indexing, as attempting to reverse the string was causing many errors due to my weak original code for it. For the second part, numberize is merely converting all unique strings, integers, or floats into tokens to be processed later on. Originally, my tokenizer was splitting spaces blindly, which caused many issues when dealing with quoted strings, such as displaying all the messages. To fix that, I had to update the regex to preserve the quoted strings as seen in the pattern variable. And for our final file, this is where all the magic happens. To start, REPL prompts the user for a scheme input, then tokenizes, parses, evaluates, and prints results in that order. The processor function reads and runs scheme code from a pre-made file. It reads our submitted file, then tokenizes it, and evaluates each expression while also printing anything if necessary. There are errors set up in case something goes wrong, such as not recognizing a file or a processing error. Then finally, the main function asks the user if they would like to type their own scheme code or submit a pre-made document. The prompt is repeated if any unidentified text is written or any number other than 1 or 2 is typed. For option 1, We opted to type our own code, and as you can see, we first start with assigning 14 to variable x. I then typed up x plus 15, which will be 14 plus 15, and you can see that we got our answer 29. I then show off the printing capabilities and also an error we would get if we entered in a blank space. For option 2, I'm going to personally show you so you can witness the program in action. First, we input which option we would like to use. In this case, it would be number 2. We then type in the file name I showcased earlier, that being test.scheme. And as you can see, I have a message that pops up right here regarding the program searching through my directory. I had to include this as originally it was not locating my file, the test.scheme, so using this helps me to understand where exactly to put my file. Other than that, you can see for yourself that all functionality works and it automatically prints displays, does addition, and reverses a list. As the text suggests, all sources with proper explanation on how they help me are listed in the README attached with all of my other files. This is the end of my presentation, and I wish you a good rest of your day to anyone who may be watching.